Welcome, everyone. I decided that we would go back to basics for this presentation. We have a lot of new customers this year that maybe don't know a whole lot about the Zee language, and I think even those of us that have been using AscentialTest for a long time can learn something new about the Zee language. I know I do all the time. So I'm going to go over the summary for you first. I'm going to talk about the different editing modes, Z mode versus the high level mode that many of us work in most of the time. I'll talk about variables because that's kind of the base of the language, right? We have to know how to declare a variable. I'll talk about that, and I'm going to talk about scope. We'll talk about conditional statements. I'll talk about the various loops, the for loop and the while loops. I'm going to talk about exception handling. This is something that I think probably a lot of us could learn something new about. I'll also talk about the class library and how to use the actions in the class library and how to create new ones. We'll talk about creating methods, and we'll talk about creating functions. So I'm going to start out talking about the two different editing modes. We have this high-level editing mode that is the default, and it provides a non-code-like look and feel. But sometimes, especially when you've become more comfortable with the product, you might want to toggle in and out of high-level mode into Z mode, and there's two ways to do that. We have a line-level Z mode that provides a way to display the current line in Z scripting mode, and then we have full Z mode that allows you to display the entire step or the entire test in Z mode. So let's take a look at that. So I've got a pretty simple step here in front of me, and most of you will recognize this as the high level mode. You know, you can see the boxes and so forth. And again, we're trying to make this look so that it's not so code-like. Now, if I want to take one line and put it in Z mode, I can just select a line and click on the lowercase z that's right here in the toolbar. And you'll notice this goes into a mode that does look a little bit more code-like. So we learn that this thing that we call set is really calling something called set value. If I click off the line, it goes back into the high level mode. Now, if I want to put the whole step into Z mode, I can click on the uppercase Z that is right alongside it in the toolbar. And now you notice that the entire step is in Z mode. That doesn't prevent you from dragging and dropping. You can still drag and drop from the Actions panel if I had the Actions panel open, or from the Actions Explorer. So you still get to use all the features, the drag and drop features of the high level mode. I find myself normally working in the high level mode until I do want to script, and then I will drop into either line mode or Z mode. So I think even advanced users probably stay in this mode most of the time and then just drop in and out as needed. Now, I said in the summary, I want to talk about declaring a variable because variables are really pretty important if we're going to be scripting. And I'm listing some of the types, not all of the types here. So we have standard types like an app object that refers to an object that you've defined as an app object. A Boolean values can be true or false. We have special types to hold values for date, time, and time. And there's the numbers, the integer, the number, the real, and string, one that people are most familiar with. There are other types as well that I'll show in a moment. User-defined types typically will define enumerated types, records, and lists. Again, this is not an exhaustive list. It just shows you the types that are used most frequently. I'm going to just talk a little bit about variables first before I demonstrate. You don't have to type the variable names or the types into the editor. You can drag them from the Actions Explorer. So let me just demonstrate that right now. So if I go into this empty step, I can come over here, and now you see the exhaustive list of standard types, more than what I had put on the slide. But let's just say that I do want to define a Boolean. I can just take the Boolean and drag it and drop it. And you notice that when we do that, we state the name of the type. So this is the type of variable. And a Boolean can only hold true or false. Now, we give a placeholder. We put a name in here, but it's easy for you to change the name to something like that. Now, I have a notation that I use. It's called Camelback notation, where I usually take the first letter to represent the type. So since this is a Boolean, I'll use a lowercase b and then the name of the variable. So this might hold a state of something, meaning whether or not maybe a checkbox is true or false. So I call it b state. That's not a requirement. It's just as well. You could just call it state if you want to. You can actually call it anything because the name of the variable is up to the user. But that's how you define a variable. You just drag it over and you drop it. It's quite easy to do. Now you can assign a value to a variable of that type. And you could do that simply like this. I'll drop into Z mode and I'll say that this is going to be equal to true. Notice that the true is lowercase. It lights up in blue. And once I do that, if I go back into high level mode, you notice that I've got a pick list there. And it's restricted, right? Because a Boolean can only hold a true or a false or a null value if you're not assigning a value to it. But true and false really the only true values for a Boolean. Now, this is something that's important to understand. A variable has a scope. Variables defined in a step or a test are said to have a scope that is local. So if I define a variable in a step, that variable is local to that step. Or if I define it in a test, it's local to that step. If I define a variable inside the body of a conditional statement, an iterative statement, or an exception statement, then it's local to that statement. I'm going to demonstrate that for you now, because this is something that's easy to miss. Here, I'm defining a variable called sname, and I'm assigning it a value. Now, you'll see when I run this, I'm going to print it. Then I'm in a loop. Now here, I'm defining the same variable name, but I'm assigning it this value. Now, some of you might be wondering, why isn't that going to cause a compile error? You know, I wouldn't be able to do, for example, this. If I did that, I'm going to get an error, right? It's going to tell me that it's already been declared. I can't declare it again in the same scope. But I can declare it inside of this while loop, in the body of the while loop, because that's a different scope. So here I've now defined a variable of the same name, but it's not the same variable. This one has a scope outside of this while loop, the body, whereas this one has, this is outside, this is inside. Now, if I didn't define the variable here, if I commented that out, then it would be this variable that is used inside of the loop. But since I'm defining it again, I'm overriding this one here. So if I run it, at the root, I get Renata. Inside the loop, and I'm going through the loop more than once, I'm going through twice, I get my name. Now, some of you might think that beyond the loop, the value would still be Brian, but it's not, because the scope of the variable s name inside the loop, the scope is here. When I come outside the loop, I get the value that was defined up here. So that's something that's easy to confuse. If you didn't know that, you might wonder about what's going on. Now, we also have something called a global variable. And a global variable is defined outside of a step, a test, a function, a method. I've defined one here in a file that I just called global.z, and you notice I created a string called sGlobal variable, and I assigned it the value hello world. Now, you might have noticed when I ran this that I did print the value hello world. So if it's global, I can actually assign a value anywhere inside of the test, because the scope of a global variable, it's declared outside the step or test, but the scope of the variable is the current test. So it's the entire test, but it's important to understand that the value of a global variable does not persist between tests. So just because you assign a value to a global variable in one test, you will not be able to read that value in a subsequent test. That's not the way to pass values between tests. Actually, there is no way currently in AscentialTest to pass values between tests without using some other form outside of the test. Like, for example, we often will write to a text file, an INI file, a database, something like that. But there is no persistence with global variables between tests. Now, you can pass values between steps in a test by using in parameters, out parameters, and shared parameters. And some of you might have some experience with that. Now, I think I've got an example for you here. Yes, I do. So let's talk first about shared parameters. So if I have a step that has a shared parameter, so yeah, my mode is shared. It's called item value, and I'm assigning it a value. And then let's see, here's my second step with shared. And here I'm just printing it. Now, if I look at the test, let's find my test. You notice that I'm calling both the first step with shared and the second step with shared, but I'm not passing any parameters between them. I don't need to do that because if I look, it's a shared parameter. It's not an in and an out parameter, it's a shared parameter. So I don't have to pass it because the scope of that shared parameter is the test. So while the test is running, any step that defines that shared parameter, and be careful, it has to have the exact same name and type, then it can be shared. And that's why the second step can print the value that was defined in the first step. I also have an example here for you of passing parameters. So let's look at those two steps. So I have a step with an out parameter. It's called item value, and it's a string, and I'm assigning it a value. I have another step called step within. Now here, I want you to notice that it does not have to have the same name. This is called value of item. I purposely did that. And here it's printing it. And the reason why is because here we're actually passing the parameter. I'm taking the value that was output, and you notice an out parameter is indicated in a in a test with this little arrow pointing to the name of the parameter. So when I want to pass it, I simply just take it and drag it like that. That's how I got that there. And you notice it references the step without, and there's the parameter name. So even though this is called item value and this is called value of item, it doesn't matter because we're now passing the value. And so when I run it, the second step prints the value that was assigned in the first and passed over to the second. So that's how parameter passing works in AscentialTest. Now I want to talk a little bit about some statements. And when we talk about scripting in Zee, we're usually talking about conditional statements and iterative statements. So we're going to talk about both of those. These are the conditional statements. That's most of what we need to do when we want to script in AscentialTest. Everything else is very draggable and droppable. In fact, even these conditional and iterative statements are draggable and droppable, as you'll see in a moment. So the if statement, it's a very classic if statement that you see in other languages. In the if statement, we pass control to the nested statements if the evaluated condition is true. So you see here in my example, I say if page to open equals, two equal signs, open employee, then it's implied we'll go in and click on PBUS open employee. So if this is true, we're going to click. If it's not true, we go to the else if it's defined and it says do nothing. Now it's important to understand that the else is not a required part of the conditional statement. It might just say if page to open equal click, and that's it. And then control would just pass on to anything else that is in the body of the step or test that we're working on. So not a difficult thing to do. And I want to show you again that if I come back here, if I go to my statements in my Actions Explorer and I drag over an if, it does create the structure at least for me. So I don't have to do it completely from scratch. If I drag over the if, I can put the condition in. And then if I'm in Zee and I hit the enter key, it would actually indent the line for me. Same thing with the else. So you do have some assistance here in the Actions Explorer. You don't have to write from scratch if you've never written a conditional statement before. Now there's other kinds of conditional statements as well. The if is the most common, but we also have something called a switch statement. A switch statement evaluates an expression. So there's an expression right here, and passes control to the first case that matches the value of the expression. First case only, because there's an implicit break at the end of each case. In some languages, every case that matches will be executed, but not in Zee. There's an implicit break here. So once a case is matched and executed, there's a break and control passes out of the switch statement. And you can see the help for it right here. And you'll note it. It says Zee does not support explicit fall through. There is an implicit break statement after each case. You'll notice there's also something called a default. And that means that if none of the cases are executed, it falls down to this default. And you might put a reminder in here that, no case was matched. A select statement is another kind of conditional statement. It's a little different. You know, up in the switch, there's one statement that's evaluated, whereas in the select, each case has its own statement. So here we say select and then case. You're basically saying if the page to open equals open employee, then click. Else if the page to open equals new employee, click. So similar, a little bit different in structure. And again, there's an implicit break in each case. And control will pass to the first statement that is true. Now let's talk a little bit about loops. There's a few different kinds of loops in Zee that we'll talk about. This first one is a classic for loop. It's an iterative statement that executes n number of times based on the parameters in the loop. And this one is a little bit ugly looking if you're not used to coding. We do plan on creating a simpler looking for loop at some point in the near future. But don't let this scare you, because once you understand it, it's really not that complicated. And you can drag it and drop it. It does give you the structure from the Actions Explorer. But if I was to interpret this for you, I'd say I have an integer of the I loop, of that a variable integer I loop, and I say for, but actually we're not using that one, we're using this one. So I probably shouldn't even have that there. For I loop equals 1, I loop is less than 10, and then we're incrementing I loop. So basically what this is doing is it's starting out with a value of 1. It's saying we're going to stay in this loop while I loop is less than 10. Every time we go through the loop, though, we're saying I loop equals I loop plus 1. That's what this I loop plus plus does. And this is just simply printing. So we would just print the value of I loop. Now, I guess this was sort of a little bit tricky. And if you think back about what I talked about, scope of a variable later, you'd know that if I print the value here, it is not going to be this I loop. It's going to be this one, which has not been assigned. There's no value assigned to it. So that's kind of a trick question there. I have something like that in a few minutes, and I'll actually show you that. In that case, there'll be a compile error. In this case, there wouldn't, just no value. Here's a different kind of for loop. I call this the for each loop, but it's technically the for in loop, as you'll see down below. It's an iterative statement that operates on a list, and it executes one pass through the loop for each item in the list. So here's a simple list. I have the list of primary colors, red, blue, and green. And the statement says for each string S color, that's the name of my variable, in primary colors, that's the list, print the value. So if I go through the list, I'm going to print red, blue, and green. Now, here's the trick here. What's the color of S color outside of the loop? Well, there's not going to be a value because there's going to be a compile error. So let me show you. So let's just run it first. So if I run it, just like I said to you, I get red, blue, and green. But watch what happens if I try to uncomment this. I get an error right away, right? Because it's unable to resolve S color. It's not been defined outside of the loop. Remember what I said about the scope of a variable. The scope of this variable is only inside this loop. It does not exist outside. So that's why we get a compile error. Here's a while loop. While is a different kind of iterative statement. It stays in the loop as long as the Boolean expression in the while is true. So here, and this is a pretty typical one, we're saying while the progress bar, we're waiting for it to exist. We're going to wait up to 60 seconds and we're going to sleep. So basically, this is a synchronization. In fact, you don't even have to do that because most of you know that progress bar .wait until exists has its own tight loop. In this case, I'm saying while true. So we're going to stay in the loop and then finally break if it doesn't exist. And again, draggable and droppable. So any of these statements can be dragged and dropped. You notice that got indented just because the else was sitting there. So you can drag over to kind of get a starting point if it's the first time that you've ever defined a loop like that. Now I want to talk a little bit about exception handling, and this is where maybe even folks that are well-versed in Zee might learn something new. So by default, AscentialTest handles exceptions for us. And that's because every time we create a test, we're actually inheriting from a base class that's called test. We don't even think about it because of the way AscentialTest is designed. We don't even really see it, as I'll show you in a minute. But when an exception occurs, when we're running a test, something called onException, which is built into AscentialTest, is called. OnException is part of the default app state, and it's not normally modified by the user. We do instruct you on how to modify it in rare cases where you need to do that. But usually we don't touch OnException, and I caution people when they do it to be really careful that they don't mask out errors, because it would be quite easy to do that. So let me give you show you what I'm talking about here. So built into AscentialTest, there's a class called test. All tests are based on this class. Among other things, this class defines a virtual method called onStart, another one called main, and in fact, you define the main of your test whenever you create a new test. OnFinish. Now, anyone that has played with app states knows that an app state has an onStart and an onFinish. So we do expect the user always to use, of course, the main whenever you create a test, but if you're using an app state, to also define an onStart and probably an onFinish. Again, onException is defined here inside the class, and we don't expect users to define that unless we really instruct them to do that. Then there's this thing called run, which we never touch. Run is what happens when you actually run a test in AscentialTest. And you see that what happens is when run is executed, the first thing that happens really is the onStart is called in your app state, and then the main. And then the onFinish. This is all what happens if an error doesn't occur. But you notice that it's in a try-catch. So if an error does occur, then we're going to pass control normally onto the onException. And AscentialTest will handle the error for you. It will report the error for you. Here's onException up here. It's going to report the error. It's going to take a snapshot and report the error. Now, what if you want to override that? You do that by using something called try-catch. And here it is, by the way. If I come back here, give myself a few lines. Under exceptions, you'll see the try-catch. You can drag it over and it'll again put the structure in there for you. And the way that a try-catch works is anything that you do inside of the try, so anything defined inside the try, will not call the default exception handler. Instead, the error will be caught here by the catch, and then you are responsible as the test developer to report the error and to do whatever else that you want to do. So it won't call the on exception. It kind of short circuits the default exception handling, and you handle it locally here. So anything you put in the try, if there's no error, then control simply passes to whatever follows the try catch. But if there is an exception, then the control is passed here into the catch. So that's how that works. Now I want to talk a little bit about building your own functions and or using built-in functions and the class library, and then I'll talk about building your own. So let's talk first about built-in functions and the class library. So the Actions Explorer provides access to all the built-in functions that we have in AscentialTest and the class library, and everything is draggable and droppable. AscentialTest prompts you for parameters, and it provides autocomplete. So let me come back in here so I can demonstrate. When I talk about the built-in functions in the class library, I'm talking about these last two nodes in the tree of the Actions Explorer. So we have some functions here, and I think a lot of people are familiar with sleep. And so again, you notice that we're prompting you for the parameters. If you wanted to get the runder, you can call get runder, things like that. The class library, again, I think most people are familiar with some of the functions or actions inside the class library. For example, if you want to connect to a database, and again, we're prompting you for the connect string. If you want to execute some SQL, if you want to get the value of what comes back from SQL, all draggable and droppable. If you want to open a text file for reading and writing, we even define the handle for you for the text file. So it's really quite easy to script using the drag and drop by calling or using the functions that are built into the function library or the methods inside of the class library. Now you can also create your own functions, because you'll notice that there's something called an add function feature in the Actions Explorer. It basically gives you the structure of a function without you having to learn how to write a function. As you'll see in a minute, you're going to provide a description and a group. You're going to provide the return type, any parameters, but then you can simply use drag and drop to create the body of the function. And then once you create this function, it can be dragged into a step or a test, just like any of the ones that are built in. So let me show you one first that's been created. You'll notice here, I've got this group called utilities. Now, normally utilities is not part of AscentialTest. This is something that I created. So I've got this utility that I wrote that's very simple. It just returns the now. If you wanted to get the current date and time, maybe you want to use it as a date timestamp, to make values in your application unique. If you need to concatenate, say, for example, a date timestamp. So you can call this this function that I created called return the current date time stamp as a string. Now, how did I get this? Well, I just came over here and I just dragged and dropped. But you'll notice I did provide a name and a description. I provided the group, and that's why it shows up in this utilities group here. It's because I defined it here that AscentialTest displays this group and puts the function that I created in it. Here's the file that it's going to be in, and here's the return type, because my function returns, not all functions return, but this one does. So I'm saying what the return type is. And then the rest of it was just gotten by dragging and dropping. I really didn't write this so much. I just dragged and dropped from the class library. And I kind of scripted around it. So not difficult to do at all. And the way to do that again is I select add function and I get an empty function that I then provide the name and the description and the group and the return type. And then again, just drag and drop. Now also this can take parameters in, out, or in, out. So it can also take parameters. And in fact, the one that I showed you did. Let's go back and have another look at it. I take in the format that the user who's calling this function wants to use in order to create that date timestamp. So it takes in the format and it returns through the return type the formatted string, the date time formatted as a string. And I want to show you also that you can call it so here I've got a step and I'm calling that return current date time string as stemp right here. I'm passing it in my format. This is the format that I want to use. And so if I run it, it gives me back, I'm catching it as a string because it returns a string. So I define a variable of type string. I call it, I give it the format, and then I print it. And here it is. So every time I run this, of course, it's going to be a little different, right? Because the seconds are changing. So this is, oh, I spelled stamp wrong. This is how you might concatenate this to some, item in your application that needs to be unique each time. Maybe you can't use the same username over and over, so you might concatenate a date time stamp to it. You can also create methods on app objects or on classes, app object classes. Now, currently we have a limitation. You know that when you have your app objects, let me just open. Let me just come in here and toggle so we see the app objects as well. So when we have an app object file open, there isn't any way, for example, to right-click here and say add a method. So I can't just add a method to the find dialog. That's coming in the future. We'll allow you to do that. Right now, what you have to do is you actually have to close your app object file, open it in the library, and I've got a second file that I'm going to open for you in a second to show you. And then you can define your method there. And then you can then reopen your app objects here. And the reason why we do that is you can't have two pointers to the same file. So when we implement this, and you do get an editor very similar to the editor that I showed you for functions, it will basically disable the app object tree so that you can't be editing the same file in two places. Okay, again, that's coming in the near term. You have to open a file here in the library, which many people are not familiar with, in order to define your function. And here you can see I've got an example of that right here. I'm inside of an app object called lookup values, and I've defined a method, select a value, right here. And again, I'll show you what it looks like for real. Here I am in lookup contract, and I've defined that method right here. It's really just like the function I showed you. It has a return type, it takes parameters, it has a body, and you can get that body from dragging and dropping from the Actions Explorer. You can also extend an app object class. If you do extend a class, that would be done in the library workspace using the Zee editor. And again, I've got an example right here. I've extended the class of text field by adding this method to it called click lookup. Pretty simple little action. Whoops, didn't mean to do that. And I want to show you what that looks like as well. So if I go into extend.z, I created that. That's not a file that's part of a normal AscentialTest project. I created that file, and I've extended the class of text field by adding click lookup. Now, if I go into my steps and tests, you'll see, come back here, if I click in this text field, because this is a text field and I did extend that class, if I come down here, you'll notice that that new function that I created is right here, click lookup. So even though it's not part of AscentialTest, once I extend that class, it will show up in the dropdown here. And that's also true for this here, this select a value that I created. Watch. If I come here and I click on this lookup contract and I go to event, we'll see it right there, select a value. So what I'm saying is if you create your own methods, either by putting them inside of an app object or an app object class, or you extend a class, they will show up here in the Actions panel, just like the functions will show up here in the Actions Explorer. So you're basically, for your project, you're extending AscentialTest to include anything that you create as a user. So just to summarize, we talked about Z mode versus high-level editing modes. We learned how to declare variables. We learned how to construct various conditional statements, the if statement, the switch, the select. We learned about for each, and while loops. Talked about exception handling, accessing the class library, and the functions as well in the Actions Explorer. We learned how to create our own methods and functions. I didn't have any new features to demonstrate for you just yet in this section.